In this video, we're going to evaluate this integral here. And when we look at the integral here, we notice that in the numerator, every term has a factor of e to the 3x. Well, there's two terms. They both have e to the 3x. The denominator term has e to the 3x. So we could cancel those. These cancel. And then we could divide through by sine of 5x. So let's just say this is equal to the integral. E to the x cancels, the 5 is going to stay there. And then the cosine of 5x over the sine of 5x, that can be written as cotangent of 5x. And over here, again, we cancel the e to the 3x, and then we have a sine of 5x here, sine of 5x there. That cancels, that leaves us with a 3, plus 3 here. So all we did here really is simplify the integral, and now we can just integrate. 5 is a constant, 3 is a constant here. So for the first part here, we can break this up into two integrals, the integral of 5 cotangent of 5x, and the integral of 3, all with respect to x. Well, the integral of cotangent of 5x is the natural log of the sine of 5x. This is absolute value here. And then derivative of 5x is 5. So this gets divided by 5 here. That cancels here. This will cancel here. And the antiderivative, or the integral of 3 with respect to x, is 3x plus the constant of integration. And there's a formula for the integral of cotangent of u with respect to u. And that's just this. But to write this in terms of u, we'd have to have u equal to 5x, so du would be equal to 5 dx. That's where this 5 comes from. So the final answer then, after canceling this here, is just right here. And let's check it here. The derivative of 3x is 3, that's part. The derivative of the natural log of sine of 5x with respect to x is 1 over the sine of 5x, so that comes to the denominator. And the derivative sine of 5x is cosine of 5x times the derivative of the 5x, which is 5. And that gives me the original integrand there. So that would be the answer working it this way. Now let's suppose that you didn't see that and you're trying to work this out. A lot of times when you don't see which method to use, whether you're using a trig substitution or integration by parts, partial fractions, whatever, the first go-to method that a lot of students, and including myself, like to go to is the U-substitution. Now the way I did it is probably the way you want to go. But if you notice here, if I take the derivative of the denominator, e to the 3x sine of 5x, you're going to get the numerator using the product rule. So let's look at it this way. U is equal to e to the 3x sine of 5x. And normally this is one approach you take with U substitution. Let u equal to whatever's in the denominator. And if you take the derivative and it happens to give you what's in the numerator, then you're in business. So in this case, du would equal to the derivative of e to the 3x sine of 5x. So it has to be functions of x here. It's a product, so we have to use the product rule. So it's first times the derivative of the second. So e to the 3x times the derivative of the sine of 5x, and the derivative of sine is cosine. So this would be cosine. So we get cosine of 5x. And using the chain rule, you take the derivative of 5x is 5, so that would come out in front, like that. And then it's the second term. That's the sine of 5x. So it's the sine of 5x. So you've got the e to the 3x. Again, we went e to the 3x times the derivative of sine of 5x, and we got cosine 5x, and then times the derivative of 5x is 5. And going back the other way, it's the sine of 5x times the derivative of e to the 3x. It's just e to the 3x times the derivative of 3x, which is 3. Again, that's the chain rule. and this is your dx. So now, this is equal to, so we're going over here, so it's the integral of, and notice, 5 e to the 3x cosine 5x plus 3 e to the 3x sine 5x dx. That's what I have right there. So all of that can be replaced by du. So that's giving me du here. So it's du, and then e to the 3x sine 5x, that's your u. And the antiderivative, or the integral of du over u, is the natural log of absolute u. And though in our case, the u is e to the 3x sine of 5x plus the constant of integration. And that should work for the answer that we have here. Because if you want to check your answer, the derivative of this would give you that expression. Derivative of constant is 0, and the derivative of this natural log of e to the 3x sine of 5x, this would go in the denominator, which is right there. And then you take the derivative of that product, and that gives you what's in the numerator. So 2 ways to work it. Probably the first way would have been the easier way, because you can go ahead and cancel the e to the 3x from the numerator and the denominator, and then proceed to solve it the way I did. Thanks for watching. We'll see you next time.